Okay, in this session, I talk about the elements in a control loop. Now, for doing that, we take the example of this shower process first. The first example we take is the. So, if you recall, the shower process had two control objectives. One is to maintain the temperature, another is to maintain the flow. Just take a look at the temperature control objective first. So, if you recall the automated shower process, so what you have to do? Also, before going to the automated shower process, let's think about the regular shower process, what it's done. So, we said that we first measure something. So, what is measured? It's the temperature. So, to measure something, what we need? It's a sensor. So, what is the sensor for the shower process? So, it's our skin that feels the temperature. And second, we have to do, we need to compare it with so the second step was to compare and calculate. So, in regular process control literature, that's known what is called this controller. So, what's the controller for the shower process? It's our brain. So, when you measure the temperature, it sends the information back to our brain. The brain decides that, okay, whether you need to do something, whether you need to change the flow rate. Now, we said that we decided to manipulate the hot water flow to maintain temperature. So, third step is to manipulate. So, this manipulation is done. So, we want to manipulate the hot water flow rate. So, that is done. What is named by the final control element. So, for our case, it's the hot water valve. So, just recall these three steps that we discussed. We need to measure something, we need to compare it with our desired value, then calculate the required action and send the information back to the process by manipulating what is called a final control element. So, what are the elements in a control loop? We have number 1 is the sensor. Number 2 we have the controller. And number 3 we have the final control element. And all of these are connected to the process. So, we have these 3 elements and all of these elements are connected to the process. So, we have the process, we have what is called the sensor, we have controller, we have the what is called this final control. So, now when you are done with this, measurement, controller and final control element, information goes back. Again, in the next step, what to do? We redo the measurement again and check whether we have reached our desired value or not. So, this process is really done in a continuous basis. That's why we call this is the loop. So, control loop. So, now we have seen in terms of a control feedback control diagram, we have seen a standard form. The standard form was something like this one. We had controller, we had valve, we had the process, disturbance, so we have seen this diagram. So for the shower process, what do we have here now? We have the process, the shower process. We have the temperature measurement is done by the skin. So this is the measurement device. We have the controller, that's our brain. And we have the final control element, that's our hot water valve. So this will be the feedback diagram for this shower process. Now let's take a second example, which one is a distillation column. Now suppose for the distillation column one objective is to maintain the top composition XD. Now how is it maintained? So first, what is the sensor here? We need a sensor. Can be what is called a composition analyzer. It can be, if composition measured indirectly by measuring temperature, that can also be done. So the first step is to measure the composition. Second step is to do some computation and calculation. For this case, it's the generic name we'll use the controller, because when you put in automated control, everything, the controller part is named as the controller. The third is the final control element is the reflux valve. So the objective was to maintain XD. We need to measure XD. We need to do some calculation and take some action. And if the control configuration tells that the reflux flow is manipulated to maintain the top composition, so the final control element is the reflux valve. So for the distillation problem, what we have here then? We have the process to be the distillation, the measurement device to be the composition analyzer. Again, the controller is the generic name, the controller, and the final control element is the reflux valve. So now, for the shower process, the output is the temperature. For the distillation process, the output is the composition. So for the shower process, the input is the hot water flow. So this is the input here. It's the hot water flow rate, if you say. For the distillation process, the input is the, say, either reflux rate or reflux ratio, whatever different terms are used. So that goes to the process. So for this case, this is manipulated by the valve, and that information going to the process. Now, as I said, there is another thing called the set point. So for the shower process is the set point temperature. For the distillation process, it would be composition set point. Now again, this is the generic error signal for both cases. Now, this in between this controller and hot water valve, there are some other elements that needs a little bit more discussion. So we'll go back to that point later in the course, but do remember that if this hot water valve element was not there in between, we would say the controller output goes to the process. That's the input. But putting that valve here, there are some other signals that need to be considered, because the controller output is something like a current signal, and the valve typically works under pneumatic valves works on pressure. So there is some other devices included that we'll discuss in later term. So in summary, for every control loop there are three elements: a sensor, a controller, and a final control element. The steps we follow the same for every control problem: measurement, measure, compare and calculate, and then manipulate. So, and these three elements, sensor, controller, final control element, do these three steps. And again, all these are done in a loop. So, that's why we call it a control loop. And also, so that there is a standard form to represent the control loop. So, this one is our regular feedback loop. So, for every process, the feedback diagram looks the same, only the elements are different for different processes.